Hey, problem set number two. I notice we have a little different look on the screen here. I'm going to need more space to work some of these problems. So what I have open on top of the of the PDF file of problem set number two is Microsoft OneNote, and I'll be writing on in Microsoft OneNote. So hopefully this will work. And still, I apologize about the handwriting. I'm sure the handwriting's not going to be much better, but at least I'll have a little bit more room to work with here. Now, as always, before we start a problem set, what we want to verify, what we want to do is make sure the two golden rules. One is that your calculator, oh, that's good. One is that your calculator is set on one payment per year. And number two is that your calculator is set on end mode, not beginning or BGN or BNG mode. Okay, so what we'll do is just like before. I'm assuming that everybody has tried all these problems. I'll go over the answers and the steps, and how to solve these problems. And the first problem is Linda has the option of making a $25,000 investment that will earn either at a rate of 10% compounded semi-annually or 9.5% compounded quarterly. Which would you advise her on? So this one's a little bit different, and it just addresses the issue of compounding periods. Now, the 25,000 is really probably extra information. What we really want to do is just standardize or change the compounding periods to the same number of periods for both of the interest rates, so we can compare apples to apples. We can compare the interest rates on the same scale, on the same number of compounding periods. So what I'm going to do is, first of all, I'm going to indicate that we're on problem number one here. And 10% compounded semi-annually, okay, I'm going to write that as in a decimal, 0.10. What's the interest rate per period if we compound 10% semi-annually? Well, 0.10 divided by 2 is 0.05. So that's the interest rate for every 6 months, semi-annual. And what I'm going to do is I'm going to raise that to the second power. I'm going to add 1 and raise it to the second power. And that equals 1.1025. I'm going to subtract 1 from that, and that's going to give me 0.1025, or 10.25%. Okay, so a rate of 10% compounded semi-annually gives us a compounded annual rate of 10.25%. So I can actually expect, if I invested a dollar at the beginning of the period and it was invested for 1 year, I'd actually make a return of 10.25%. And let's compare that to the second investment choice of 9.5%, or 0.095. Compounded, what do we have here? Quarterly. So I'm going to divide that by 4. And that equals 0.0238. And what I'm going to do is I'm going to calculate the compounded annual rate. I'm going to add 1 to it, and take 1.0238, raise it to the 4th power, okay, and that's going to equal 1.0984. Getting off track. Subtract 1. And that's going to equal 0.0 984 or 9.84%. Okay, so now both rates are on the same scale or the same periods. And simply, which would you prefer as an investment option? Would you rather invest in something earning 10.25% or something earning 9.84%? Okay, and the answer is clear then. You'd pick the first option. You'd prefer a 10% compounded semi-annual rate versus a 9.5 compounded quarterly rate. Okay, so you pick the first investment option for this choice. Now, I wish they did the problem a little bit differently here actually, to demonstrate something. And I'm gonna try to scroll down here. Give us a little bit more space. Now, what if we had a third option? I know it's not in the problem here, but what if we had a third option of 10% compounded quarterly? Okay. And we're going to compare that to 10% compounded semi-annually. So we're going to look at 10% compounded quarterly. Now, if we have 10% compounded quarterly, take 0.10 divided by 4, and that's 0.025. All right. Add 1, and then raise it to the fourth power in this case. That's 1.1038, I believe. Subtract the 1. And that gives us 0.1038, or 10.38%. Now this time, given a choice of 10% compounded semi-annually, okay, and 10% compounded quarterly, which would you choose? Well, in this case, you choose 10.38%. And that's that I think that shows more clearly, I think, what the problem is trying to demonstrate, that the more, given the same interest rate, initial interest rate, the more compounding periods, the higher the effective annual interest rate, and the more money you'll actually make. So if someone offers you any interest rate, and they're the same interest rate, and there's two different compounding periods, take the one with the higher compounding periods. The more compounding periods, the higher, the effective annual interest rate. And this is why credit card companies like to have a lot of compounding periods, don't they? Okay, they're charging you interest. All right, so this is, their investment is lending you money, and that's why they have daily compounding rates. So the more compounding periods, the higher, the higher the interest rate. Okay, let's look at number 2. And let's try to clear this up. So we're looking at 2 now. Gotta switch to the pen. And number 2 says an investor can buy a tract of farmland that he believes will sell for $50,000 in 8 years. His required rate of return for this type of investment is 12% per annum, compounded monthly. Okay, so this started out like a familiar problem from problem set 1, but the difference here is the 12% is compounded monthly. How much should he pay for the land today? And just some simplifying assumptions here, just to make it a simple problem. Assume no taxes or periodic cost involved. All right. So first of all, let's go back to our old rules here, our old process for solving these types of problems. Number 1, identify what type of problem we're trying to solve. And this is a present value of a lump sum, right? So we're going to be solving for a present value. And one of the tricks here, you might even circle it. Let's see if I can jump back and forth. Yeah, you might circle monthly to remind yourself that we're going to be dealing with monthly payments here, which is the big issue or trick of this problem. And then go back to the old standard here, set up the time value of money menu, put a box or identify what you're trying to solve for, and then plug in what you know. But do make sure that your calculator is set on one payment per year, and also you're in end mode, and also your time value money registers are clear. This time, what is going to be, or what are we solving for, first of all? We're solving for a present value, a PV. So I'm going to put a box in there. That's what we're going to compute. This time, what's going to be n? How many periods are there? And don't say 8, okay? 8 is wrong because uh, it's 8 years, but we have monthly compounding periods. So it's actually going to be what? 8 times 12 or 96. N is going to be 96, which is 8 times 12. The interest rate. Okay, and notice N is in what periods? It's in months. So remember, another rule is that N and I always have to match in time periods. And also remember, our calculator is set on one payment per year. So okay, the interest rate is 12% per annum compounded monthly. So what's the interest rate per period? It's not 12%, that's per year, and N is in months. So I has to be in months, so you take 12 and divide it by 12. Okay, and enter it directly into into the interest rate register. So just take 12 divided by 12. Uh, don't hit equal. Okay, it's not going to matter so much in this problem, but if you hit equal and type it again, there might be some rounding. But if you enter 12 divided by 12 and input it directly into the interest rate, there'll be no rounding of whatever you put in there. So that's how you want to do it. And now, the interest rate is essentially 1, right? 1% per month. And N and I match up now. N is in months. The number of the periods in this problem is months, not years. N is in months, and I is in months. So they both match, and we can proceed on. Okay, payment. What's going to be in payment? Well, nothing, right? Make sure that's empty or clear. Put 0 in there if you want. And future value is what? 50,000. And I'll leave that as a positive because that's money going to be going into the subject's pocket. So compute present value, and what do you get? Well, it's going to be a negative $19,236.15. And that should be the answer to this problem. $19,236.15. So if our investor bought the tract of farmland for $19,236.15, held it for 96 months, 8 years or 96 months, and did in fact sell it for $50,000 at the end of the 96 months, that investor will achieve exactly a 12% per annum return. Okay, number 2, or no, I'm sorry, we just did number 2. Number 3. Let's see if we can get number 3 on the screen there. Number 3, Jack deposits $1,000 at the end of each month into an account that will earn interest at an annual rate of 10% compounded monthly. How much will he have at the end of 6 years? Again, sounds like a familiar problem set number 1 problem, but we have a special issue here again, right? We have the monthly compounding issue. So that's the new aspect of this problem, not just more practice. So let's get a little bit more room here. And we're looking at problem number 3. Again, make sure your calculator is still set on 1 payment per year in end mode. And what are we solving for here? Okay, yeah, the key there is what will we have at the end of 6 years. So that's definitely a future value. So as I'm starting to set up the time value of money menu, again, you might make sure your registers are clear, your calculator is clear for a new problem. And I'm going to put a box in future value to remind myself I'm going to be calculating a future value. And in this problem, what is n? Okay, again, don't say 6. Okay, n's not 6. N's going to be 6 times 12 or 72. So n is 72, so put 72 into n, which again was 6 times 12. 6 years with monthly compounding. Now I. Once again, make sure our calculator is set on 1 payment per year. Okay, the procedure I'm using, what I'm going over, we're assuming that the calculator is set on 1 payment per year. If you switch your calculator to 12 payments per year, what you do is you just enter 10 for 10%, and the calculator automatically divides it by 12. But again, I don't like to do that because I leave my calculator set on 1 payment per year all the time, and I just remember to make that adjustment in the interest rate when necessary. So what I'm going to do here is I'm going to enter 10, and because my calculator is set on 1 payment per year, I'm going to go ahead and divide it myself by 12. So I'm going to enter 10, divide by 12, and input it right into the into the interest rate key. In this case, we do have rounding, okay? Because 10 divided by 12 is 0.8333 repeating. And if I did 10 divided by 12 equal and got 0.8333 repeating, and I took 0.833, let's say, and put it into I'm going to have some rounding, and it's going to be significant, and your answer is going to be wrong. So what I'm telling you right now is very important to prevent rounding in the I key. And you got to figure out on your calculator how to overcome that. But you don't want to go 10 divided by 12 and put in 0.83 or 0.833 because there's going to be some rounding. You want to put 10 divided by 12 directly into the I key so the calculator has all the digits beyond the decimal place. Okay? And now n and I are in same units. They're both in the same units in months. So that's the key. That's what we never want to have different units for n and I. What's PV going to be? Well, PV is 0 or empty in this case, so make sure that's clear. Payment. Okay, the payment is 1,000. I'm going to make it a negative because that's money going out of the subject's pocket, right? Jack's going to deposit. That's a cash flow out. So I'm going to leave it as a negative. And then compute or solve for a future value. And Jack is going to have $98,111.31. So the answer to number 3 is $98,111.31. So Jack will have that after the end of 72 compounding periods or 6 years. Okay. Let's take a look at the next one. First, I'll scroll down a bit. And we're looking at number 4. Number 4, Best Properties is considering an investment that will pay $1,000 at the end of each year for the next 15 years. It expects to earn an annual rate of return of 16% on its investment. How much should the company pay today for its investment? Now this time it says nothing about monthly compounding, so I think we're back to just annual compounding. So this problem should be, the easiest one so far. Should be pretty straightforward. In fact, hopefully you can tell me how to set this up. But number 4, first of all, what am I going to be solving for? It says, how much should the company pay today for its investment? So as I'm writing my time value of money menu, you're probably, hopefully you're doing two things: clearing your registers, your time value money registers, and thinking about what we're solving for in this problem. And what am I solving for? Of course, a present value. What should the company pay today? Okay, so I know I'm solving for a present value. So I'll put the box there and then fill in what I know. What's n going to be? N is just simply 15 years this time. I is 16%, so I'm just going to put in 16. Once again, my calculator is set on 1 payment per year. And also it's an end mode. My payments, okay, my payment is $1,000. And I'll make that a negative because that's a cash flow. That's money going out of my pocket. And I like to follow the money with my signs. I'm going to make sure future value is empty or clear, or put 0 in it to be safe. And then compute, solve for present value. And what do you get? Well, I get negative 5,000. Oh boy, it's tough to write. $575.46. So that's $5,575.46. That's what best properties should pay today for an investment that will pay $1,000 at the end of each year for 15 years. And if that happens, and if they pay $5,575.46, their return is going to be 16% on this investment. And we could actually call that what? We could actually call that their internal rate of return. So in that case, it would be the 16% would be their internal rate of return. Okay, next, let's scroll down. And we're looking at number 5. And number 5, we have Megabucks Development Company is evaluating an investment that will provide the following returns at the end of the following years. Year 1, $12,000. Year 2, $6,500. Year 3, 0. Year 4, $8,000. Year 5, $4,500. Megabucks believes it should earn an annual rate of return of 14% on its investments. How much should Megabucks pay for this investment? Okay, so here we have a new one. Okay, we have a series of uneven cash flows, and we talked about this when we talked about calculating NPV and IRR. Probably the best way to do this, and the quickest way at least, is to use our calculator menus, our cash flow menus on our calculators. So let's do number 5 here. And number 5, I'm going to find my cash flow menu, and I'm going to clear it out, and I'm going to enter the cash flows. And cash flow 0, I'm going to leave as 0, right? There's no initial investment specified in this problem. We just have cash flow in year 1, 2, 3, 4, and 5. And actually what we're doing, we're just trying to calculate the present value of those cash flows. Again, if those cash flows were even, we could just calculate the present value of an annuity on our time value of money menu. But the problem is that these cash flows are uneven. They're not the same. So we could discount each cash flow back as a lump sum, one by one. Or more efficiently, what we could do is use our cash flow menu and use the net present value key to calculate the present value of these cash flows. Again, it's technically not a net present value because we're not netting out any CFO, any initial investment cost, any first year negative cash flow. But we can still use it, and this is the quickest way. So CFO is going to be 0. CF1 is going to be 12,000. Okay, input that one, and if the calculator asks or specifies the number of times or number of periods, just leave it at the default of 1. Hopefully that's the default. Cash flow number 2 is 6,500. Okay, and again, if the calculator asks, you just want that to be entered one time. Cash flow number 3, okay, this is 0, and you need to put that in. Okay, you can't skip cash flow number 3 and put in 8,000 for cash flow number 3. That's incorrect. That's wrong. You're not getting $8,000 in year 3. You're getting $8,000 at the end of year 4. So you must put in 0 to solve this correctly. Cash flow number 4, now that's the 8,000. Cash flow number 5 is 4,500. Okay? Whenever we calculate a present value or net present value, we need to specify an interest rate, and the problem gives us a 14% discount rate. So input 14% in your calculator and its interest rate uh, register associated with the cash flow menu, and then find the net present value key, although it really bugs me because this is not a net present value calculation, but we'll survive here. And what do you get? It might take a second, but the calculator should report a net present value of $22,601.66. This is a present value of the future benefits, which are cash flows 1 to cash flow number 5. Okay, so that's the present value of the benefits. It's not a net present value. Now, number 6, we can read number 6 there. Larry is considering the purchase of an apartment project for $30,000. Larry estimates that he'll receive $7,200 at the end of each year for the next 4 years, and then $7,900 at the end of each year for the following 3 years. If he purchases the project, what will be his internal rate of return? Okay, interesting. This is our first internal rate of return problem. And also, we can use the times or the number of payments feature in the cash flow menu. This would be a good problem for that. So let's clear your cash flow menu, and I'm going to clear out some space to work with. How about some new space? And this is problem number 6. And then once your cash flow menu is cleared, let's enter the cash flows. Our cash flow number in year 0, our initial investment, and whenever you calculate an internal rate of return, you need a negative CFO. You need an initial investment amount. And the CFO, the initial investment is negative, and it must be entered in as a negative. 30,000. Our cash flow number 1 is 7,200. And here's where you can use the times key, or the number of payments key with the cash flow menu. The HP, I think it asks for the number of times, and the default is 1. But going back to the problem, Larry estimates that he'll receive 7,200 at the end of each year for the next 4 years. So what I could do, is I could put, CF1, CF2, CF3, CF4 as 7,200, or I could just go 4. And the calculator will recognize that the 7,200 is occurring for four periods. Okay, so I'll do it the longer way next to it, but this is an opportunity to use those shortcuts. So I could go cash flow number 1, 7,200. Cash flow number 2 is 7,200. Cash flow number 3 is 7,200. And cash flow number 4 is 7,200. Or the same thing would be cash flow number 1 4 times. Going back to the shortcut way, let's input the next cash flow. Cash flow number 2 then would simply be the 7,900 because Larry's going to invest 7,900 at the end of each year for the following 3 years. Okay, so what I could do is I could tell the calculator to recognize that cash flow for 3 periods, for 3 years. It occurs 3 times. Or going back to the longer way, I could enter that cash flow 3 times in year 5, year 6, and year 7. So either way, you should get the same answer. Okay, you're just using a shortcut the first way, and you're explicitly punching in each of the cash flows the second way. So our goal again is to compute an internal rate of return. And again, with an internal rate of return, we're solving for a discount rate, the discount rate that it makes the net present value of these cash flows equal to 0. So we don't specify an I. We're looking for an I. So find on your calculator the IRR button and go ahead and hit it. And what do you get? Well, the internal rate of return. And again, notice the calculator might take a few seconds to come up with this because that's because the internal rate of return calculation is an iterative process. Okay, it can't solve for IRR directly, so what it does is it tries some discount rates and calculates the NPV, see how close it gets to 0, and then hones in on it from there. But it should come up with 15.94%. So the internal rate of return, either way you do it here, should be 15.94%. All right, and our last problem number 7. Let's move that up. Get the pen back. And we're doing number 7. Jill is buying a tract of mountain land. The purchase price will be $80,000. The seller has agreed to finance 75% of the purchase price and 25 annual payments at the end of each year at 9.5% interest. How much will Jill's mortgage payments be? All right, so I think we did a couple of these in the first problem set, so this should be practice. First of all, while I'm setting up the time value of money menu, remember the golden rules of the calculator. Make sure you're at 1 payment per year. Make sure you're in N mode. And also clear your time value money register if you haven't done that already. And what are we solving for? Well, we're solving for a mortgage payment. So let's put a box in the PMT and then plug in what we know. We know N is 25 years, and it is annual payments again. So we leave it at 25 years. The interest rate is 9.5%, and N and I are in the same units. And that's 9.5% per year and 25 years. The present value. Okay, be a little careful here. You just don't plug in numbers that you see in the problem, but what you have to do is read the problem carefully. And we know that the purchase price is $80,000. That's not the mortgage amount, and we're calculating a mortgage payment. So what you want to do is calculate the mortgage amount. So Jill is going to borrow 75% of the purchase price. Or 60,000, right? 75% of 80,000 is 60,000. So that's going to be the mortgage amount. And that's what we're going to plug into what? Present value or future value? Well, that's going to be the present value, right? And I'll leave it as a positive because that's money going into Jill's pocket to buy the property. But she's going to have to make payments over 25 years. Make sure future value is empty or 0, because after 25 years there's going to be a 0 balance on this mortgage if she makes all 25 payments. It's going to amortize to 0. And then calculate payment. And what do you get? It should be it's going to come out as a negative $6,300. $357.56. Okay, so we winded up with an easy one, huh, at the end. That's nice. Well, we're going to go back to the notes and talk more about mortgages and mortgage balances and points on mortgages and a few other things, and then come back to problem set number 3. But signing off for now. Bye.